Social networks. When asked the question, what is a social network, what comes to mind? Take a few seconds to think about that. Now, if I was to ask everyone in this room what they thought of us as a social network, we probably have, what, 5 different responses? One being, Facebook. You guessed it, Facebook. Number 2 would probably be Twitter, Google+, and how about circle of friends? That's a social network, right? So what I want to talk about today is social networks as far as a graph theoretical perspective. All right? My goal today is to increase your understanding of social networks and to also be able to apply this theory to real life situations. And by doing that, I'll be talking about the Crackart advice model, and this is a very interesting model. I can't wait to talk about it. When talking about social networks, it's hard to talk about social networks without mentioning the DeGroot model. The DeGroot model basically is, it's a simple model that helps us understand how the structure of a social network influences spread of information and also helps us form opinions. And by doing this, the DeGroot model talks about 4 components. The T matrix, transition matrix, which I'll get into, the initial opinion, which is a set of beliefs, and then the updating of these set of beliefs, which eventually leads us to a convergence. The transition matrix. The purpose of the transition matrix is to, basically it's a mathematical representation of a social network. And basically we put the social network in terms of a matrix that allows us to test it. Because if we just have a social network without any mathematical representation, it's hard for us to perform tests. So we put it into a transition matrix, n by n being the number of people in the network. So in the example that I'll be talking about, it'll be a 3 by 3 matrix. It's a 3-person network. So basically, each row represents the opinion maker. So in this example, this is person 1, person 2, person 3, and then this is person 1, person 2, person 3 as well. But for the columns, it's the people's influences on the opinion maker. So basically what this means is person 1 bases his or her beliefs on 2 and 3 equally, 50-50. And person 2 bases his or her beliefs 100% on person 1. And we'll see when we get into a diagram how they come together. Person 3 bases his or her beliefs solely on person 2. So here's a diagram that I made, and it's a 3-person network, and basically what's happening here, when I put it together and I was looking at it and I said, so person 2 looks at person 1 100% for their opinion, bases their opinion 100% on 1. What could this represent in real life? And I thought, well, I like to run, so I picked running as the activity, and let's just say these 3 people are talking about, and I'll get to it in the next slide, but basically what I decided was, well, if you're looking for someone's opinion 100%, you're relying 100% on them, it sounds like maybe they're the trainer, right? So you're looking at your trainer for advice. Of course, I mean, it's probably not the case for everyone some people might ignore your trainer, but I rely on my trainer if I had one. But then,
I'll stand in for you.
Thank you. So, and then the relationship between 3 and 2, 3 relies on person 2 100%, and I thought about the father-son relationship, me being a father, and I would hope that my son would rely on my opinion 100%. You can always hope, right? Initial opinion, this is very important. So basically we start off with a set of beliefs, right? Each person in the network, in our case the 3-person network, has a set of beliefs. And what we're talking about related to this network is the likelihood of someone engaging in running. So the initial opinion can be displayed in a column vector, an n-dimensional being 3 dimensions for us, because it's a 3-person network. This would mean that the first person is, the trainer, is 80% likely to run. The second person is the dad, 40% likely to run. And the third person, the son, is 20% likely to run. And then what happens is we go through a process of updating, and I'll explain this 2 ways. Basically, there's a mathematical explanation, which you take your T matrix, you multiply by itself using linear algebra, and then you multiply the T vector, the T matrix by the opinion vector, and it results in a new opinion vector. In layman's terms, what is happening between the 3-person network is that these 3 people, the dad, the son, and the trainer, talk, right? They're talking, they're sharing their beliefs, and it leads to an update. And then eventually, the more updates you have, it leads to a convergence. Convergence being that eventually when you have 2 consecutive updates with the same opinion for each individual, that results in a convergence. The information has been spread among the network, and there's no more gaining new information. We've reached a consensus. All right, now I want to apply it to real life. Let's talk about the crack hearts advice model. Basically what this is, it's about a manufacturing company. 21 managers work for this company, they were surveyed, and each manager seeks advice from another. Basically, how I'm going to talk to you about this, how I'm going to demonstrate what this model is about, is I'm going to talk about a table and then a diagram. Let's go to the table first. So basically what this is it's 21 managers, and the S, if you can see it, represents the influence that each manager has on the rest of the managers, right? And then there's 4 other characteristics that go along with each of these managers. Being the level, which is a 1, 2, or 3. There's one person that is a 1. He's the top guy. There's 4 2s. They're kind of like middle management, and then the rest are 3s, kind of like supervisors. So, and then there's apartment, age, and tenure, and I kind of want to talk about the tenure. The tenure being the amount of years that each of these managers has worked at this particular company. One interesting thing, and you probably a few of you have noticed, there's some zeros here, right? So basically 6, 13, 16, and 17 have 0 influence on the rest of the managers. And what's interesting, if you look at number 6, he's been there 28 years, and he has no influence on the rest of his peers, the rest of his managers. And then another thing that I noticed was if we compare 18 to 21, right? 21 has twice as much influence on 18. However, if we compare it to the number of people that they advise, 18 actually advises more people, 12. 21 advises 8. And that's because the 8 people have more influence. So that makes his influence more, because he's influencing, even though it's left fewer amount of people that he advises. And this is the diagram, if you will. It basically shows the relationship. I'll point out this 6 and then the other numbers that had zeros. See, there's no arrows going towards him. Basically what this represents, if an arrow's going towards, that's someone seeking advice. So 6 is seeking advice from 21, but no one is seeking advice from 6. And I believe that's the guy that's been here 28 years. All right, so in conclusion, hopefully your understanding of social networks has increased, and by applying this theory to application and seeing real examples. And I just want to take this time to thank my faculty sponsor, Dr. Curran. I appreciate everything he's done for me and all the knowledge he's shared with me. I got to thank my donor, Kevin Janisek. He's helped fund the SURF program for me. I appreciate it very much. I got to thank Delta Dental as well. And I got to thank my wife for sure. I wouldn't be here without her. She's working and allowing me to come to this fine institution to study. So thank you very much. Any questions?